Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the chain rule. The chain rule is always a concept that students struggle with. So let's start with something that we're familiar with. If we had a polynomial function, f of x is equal to 3x cubed minus 4x, we know how to differentiate that function. But that function might be inside another function. For example, I might have f of x equal to 3x cubed minus 4x all to the power of 2. Now in this particular example, we could expand this and then differentiate, because then we would have another polynomial function and we'd know how to differentiate that. But if this power was 10, I don't think we really want to expand all of that. If it was 1/2 or any other fractional exponent or a negative exponent, we wouldn't be able to expand it. So we are going to want to differentiate this when it's in this form, and this is called a composite function. This means we have a function inside of another function. So we have this polynomial function inside a power function. Later on, when we talk about other derivative formulas, we get into derivative of different trig functions. So this could be, the function could be the sine of this polynomial function. We get into log functions, so we could have the natural log of this function. We could get into exponential function, so we could have e to this function. So there are all sorts of composite functions that you're going to encounter. And what the chain rule does is it allows you to differentiate composite functions. But I'll just try to explain it first and then I'll give you the actual definition. The whole idea of the chain rule is you start with your outer function. So in this case here, my outer function is a power. So I start by differentiating my power. Once I found the derivative of the power, then I go inside and then I take the derivative of the function inside. So then I would take the derivative of this. And we can have a composite function of numerous functions. We could have the y equals the natural log of the sine of e to the 3x cubed minus 4x. I mean, there's a combination of 4 functions in one, but we will use the chain rule to go through step by step, starting with the outside function, then going inside that to the next function, take the derivative, then go to inside that, take the derivative, and so on. And that's typically what students forget, is they forget to keep going. If you have a composite of 4 functions, your derivative should have 4 factors. So let's take a look at what the chain rule is, and then let's use it to differentiate this particular function. The chain rule is used to build up all of the other derivative formulas that we're going to take a look at. So the next one that we're going to talk about is called the power rule, which is how to differentiate a function like this. And then all of our derivatives of non-algebraic functions will use the chain rule. So let me explain what the chain rule means. If we had y is equal to a function of I'm going to call it u. So y is a function of this function, so that it's raised to the 10th power. So it's like this would be my u. And then if u is a function of x, so we'll just use a different letter and say it's g of x, I can find the derivative of y with respect to x. And the way that you find the derivative is you first of all differentiate y with respect to u, and then you multiply that by the derivative of u with respect to x. And you would continue on with how many ever functions you have in that one function. But the notation is tricky, it's hard to understand, but hopefully as we go through examples you'll catch on. The biggest thing that people forget is this part here. So if we took a look at this example here, it's like y is equal to u to the 10th power, and u would be equal to 3x cubed minus 4x. All right, so I've got some function u raised to the 10th power. That function u is this. If I were to differentiate u with respect to x, it would be 9x squared minus 4. If I was to differentiate y with respect to u, it will be 10 times u to the 9th. So according to my rule, dy dx of this particular function will be equal to dy du, which is 10 u to the 9th, times du dx, which is 9x squared minus 4. Now we don't want to leave u in our result. We want to write everything in terms of x. So we're going to replace u with how u is defined, which is 3x cubed minus 4x to the 9th power times 9x squared minus 4. So the chain rule allowed me to find the derivative of what's called a composite function. So I have a polynomial function inside a power function. So I first of all deal with the power function. So it would be 10 times u, which is this function, to the power of 9. Then we go inside the power and look at the polynomial function, and we find the derivative of it, which would be 9x squared minus 4. So my end result will be my 10, which is like the n, times this function to the n minus 1 to the 9th power, and then go inside the function and find the derivative and multiply by that. That is using the chain rule with a particular type of function, power function. Let's do a few more examples just with power functions. I don't want to get into the non-algebraic functions at this point. We will get to those later on. But let's just look at power functions and practice a few more of these. I'm going to do this question the same way I did the previous question. There's going to be a lot of notation that really is not going to be necessary, but I'm hoping it helps you understand. So what I'm going to break this down into is this is like y equals u to the power of 3, where u is 5x squared minus 4. So the derivative of this with respect to u will be 3u to the power of 2. The derivative of this with respect to x will be equal to 10x. So now I'm going to put them together. Remember, dy dx will equal dy du times du dx. So that will be equal to dy du, which is 3. Now instead of writing u, I'm going to actually write what u is equal to. So the 5x squared minus 4 to the power of 2. Then I have to multiply by du dx, which is 10x. And I would probably combine this, I would multiply 3 times 10x to get 30x times 5x squared minus 4 to the power of 2. Let's take a look at this example. Same idea. If we were to call this u, y would be u to the 1/2. And u we're defining as 2x to the 4th minus 5x cubed plus 10. So the derivative of y with respect to u will be 1/2 u to the power of 1/2 minus 1 is negative 1/2. Then I differentiate u with respect to x. So it will be 8x cubed minus 15x squared. Putting it all together, I use this my chain rule. So dy dx, so the derivative of this function now with respect to x will be 1/2 of u, which is 2x to the 4th minus 5x cubed plus 10 to the power of negative 1/2. Then that's my dy du, but instead of writing u, I put the actual function in terms of x. And then I need to multiply that by du dx. Du dx is simply the derivative of what's inside the function. Be 8x cubed minus 15x squared. What I want to do with this example is I want to do it using the chain rule, and then I want to just check my results by expanding this and just making it a polynomial function instead of a polynomial function inside of a power function. And then you will see the results are the same, so you'll hopefully understand that the rule works. So if I treat it, first of all, as a composite function, a polynomial function inside a power function, and therefore I need to use my chain rule, I'm defining y as u squared. And inside my square function is u, which is 4x minus 3. So if I differentiate this with respect to u, it will be 2 times u to the power of 1. And then if I differentiate this function with respect to x, it will be 4. Remember, the chain rule says dy dx of a composite function will be dy du times du dx. So the derivative of this with respect to x, so the derivative of y with respect to x will be, first of all, dy du, so 2 times, and instead of writing u, I'm going to write what the function is, 4x minus 3, to the power of 1, and then we multiply by du dx, which in this case is 4, which I would clean up the 2 times the 4 and say this is 8 times 4x minus 3. Let's do a check just because we can with this particular example. I'm going to expand this, so y will equal 4x minus 3 times 4x minus 3. So when I FOIL that, I'm going to get 16x squared minus 12x is minus 24x. Negative 3 times negative 3 is plus 9. So I just expanded this function and just made it into a polynomial function. It's no longer a power function. Now I can differentiate this. Will be 32x minus 24. If we were to multiply our 8 to each term here, we would get the same thing. So hopefully you understand that it does work. And my biggest piece of advice is don't forget your du dx factor. That's the biggest mistake that students make with these composite functions. I'm hoping that you have a better understanding of the chain rule after seeing the examples that we've done. The next video is going to be on the power rule, which is basically what we were doing with these examples. We were using the chain rule with powers of polynomial functions. We will come back to the chain rule again and again when we talk about derivatives of transcendental functions, which is non-algebraic functions down the road. But for now, we're just going to be using it with the power rule, so we'll be reinforcing it in the next video.